Alright, this video is on additive and multiplicative relationships. And this actually goes right along with our review of input-output tables. Okay, additive and multiplicative relationships. It's really just like, it's really big words talking about something you already understand. Okay, so you remember our talk about input-output machines. You know, so something ridiculous like this, right? And you put a number in, and you get a number out. Okay, so you know, and we make sound effects, right? You put a number in, and it goes boop, 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 and then it comes out. Okay, and what happens when the number's in the machine is either you're adding something or you're multiplying. I guess you could be subtracting or dividing, okay? So when we talk about additive and multiplicative relationships, we're just talking about what kind of machine do we have? You know, do we have a machine that is adding or subtracting? And those two go together, right? Okay, adding or subtracting. Okay, or do we have a machine that multiplies or divides? Okay, because those two go together. All right. So, you know, input-output machines and tables have rules. Okay, so if I have a table, let's see, if I have a table, let's make it right here. Whatever I put in, I get something out. Okay, and we're starting to look at that as an XY, right? Okay, and I'm actually going to give myself another table over here. And I'm going to talk about putting something in this one and getting something out. And again, what you put in, we're starting to call X, and what you get out, we're starting to call Y. Okay, so let's say that I put in a 0. Okay, so this table, I'm going to ask you at the end, I'm going to ask you what the rule is for this table. Okay, if I put 0 in, I get 2 out. If I put 1 in, I get 3 out. Okay, if I put 2 in, and when I say in, I'm saying like if this was in a machine, you know, I put the 2 in, I get 4 out. And if I put 3 in, I get, oh, not 6, I'm sorry, 5 out. I get 5, okay? What's my rule, okay? Well, how do you get from 0 to 2? You add 2. How do you get from 1 to 3? 1 plus 2 is 3. So each of these, I'm doing plus 2, right? Okay, so the rule for this one is plus 2. So this table right here is additive because I'm adding, okay? Now over here, I'm going to put in 0 and I'm going to get 0 out. When I put 1 in, I'm going to get 2 out. When I put 2 in, I get 4 out, and this time when I put 3 in, I do get 6 out. Okay, so what's the rule for this table? Okay. Well, this is a, let's see, 0 times anything is going to be 0, but 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6. So the rule here is times 3, I'm sorry, times 2. I just said the 3, so I was thinking about times 2. Okay, and because I'm multiplying, this table is multiplicative. Okay, so, you know, these are just big words. You know, like when you learned, you used to say, well, these are timesing. I'm timesing. Well, I'm multiplying. I'm showing a multiplicative relationship. You know, it's getting fancier. But it's the stuff that you already know. Okay? Now, here's where we connect it back to the idea of an equation. Okay? And we just talked about writing equations. And when you write an equation, you say that y equals, okay, and this is where whatever my x was, okay, what did I do here? I added 2, okay? So, what I'm saying is for any number that I add, to find my y, to find out what's over here, to find my output, I take whatever I put in and I add 2, okay? Over here, in order to find this y, I have to multiply by 2, and I write that by putting a 2 next to the x, okay? Yes, I could write 2 times x, but then it looks like 2xx. I could put 2 and then a dot and then the x, but usually this is how we write it, okay? I can make a generalization then that anytime I have an additive relationship, I can use the formula y equals x plus a. Okay, and I know that a is new. Okay, I'm going to talk about it. For any multiplicative relationship, y equals a times x. Okay, in this case, okay, a is whatever number the rule is. Okay, so this was a plus 2, so plus a plus 2. This was a times 2, so times a times 2. Okay, and the y is your output, and the x is your input. Okay, and I'm going to go ahead and write that. So the y is your output, and that's true in both cases, okay? This is the output, and this, the x, is your input, okay? Another way to say the output and input is to say that the input is the independent variable. Okay? These words mean the same thing. Okay? Input and independent variable mean the same thing. We're just getting fancy, okay? Just like up here, we're timesing, we're multiplying, we're showing a multiplicative relationship, okay? I'm putting a number in a machine. I've got some input. I have an independent variable, and I should have an L in there, okay? The y, the output, is also called the dependent variable. Okay, so the words output and the word dependent variable are the same thing, just getting fancy. It's whatever number I get out. This is the output. This is the dependent variable. Okay, a variable is just a number that changes. Okay, you have variables in science, you have variables in lots of things, but it's just a number that changes. Okay, so there is one more thing that you need to really understand about additive and multiplicative relationships, and I'm going to go ahead and use a new page for this. Okay, and on this page I am going to draw, let's see, I'm going to go down and then over, and I'm going to do another one, down and then over. Okay, and I'm going to give myself some lines. I'm drawing myself a little bit of a coordinate plane here, okay, and I'm spacing out the lines, and then these axes keep going in any direction, okay. So I'm going to think about the tables that I had over here, and I'm going to graph each one. I'm going to graph y equals x plus 2, okay? y equals x plus 2. Okay, I can graph that by making a table, and I already had a table over here, but you know, I can make another one. It's really not a big deal. Okay, x, y, okay. So again, if I put in 0, okay, and again, this right here is called my input. Okay, I'm just going to keep repeating these words because it's one of those things that's not going to get comfortable until you just keep trying it. Okay, so this is my input. It's also my independent variable. Independent variable. Okay, I ran out of room, so I'm just going vary. Okay, and the y is my output. Okay, and it's also called my dependent variable. Okay, and we're going to talk more about the words independent and dependent variable, but I want you to kind of start getting the idea. So if I put in a 0, if x equals 0, 0 plus 2 is 2. If I put in 1, 1 plus 2 is 3. 2 plus 2 is 4, and 3 plus 2 is 5. Okay, so I can turn these into coordinates. Okay, 0, 2, 1, 3, 2, 4, and 3, 5. Okay, so 0, 2, my x always goes first. 0, 1, 2 is right here. Okay, 1, 3 is right here. 1, 2, 3. Okay, 2, 4, 2, 1, 2, 3, 4, and 3, 5. 1, 2, 3, 1, 2, 3, 4, 5. Okay, and so I've got 4 lines there, and looking for something to use as a straight edge. Okay, so, and then there is my line. Okay. Now, next to this, okay, I'm going to recreate my y equals 2x. Okay, y equals 2x. Okay, so I'm going to make my table again, and I'm going to think about my x and y. And remember, okay, the x is the input, or the independent variable, okay, and the y is the output. It's what I get out, and it's also called the dependent variable. Dependent variable. Okay. So, if I put 0 in, y equals 2 times 0. 2 times 0 is 0. Okay. If I put 1 in, 2 times 1 is 2. If I put 2 in, 2 times 2 is 4. And if I put 3 in, 2 times 3 is 6. Okay? And then I can graph this. Okay? So right here, start with 0, 0. Of course, that's the origin. And then 1, oh, sorry, I meant to write these out. 0, 0. Okay? 1, 2, 2, 4, 3, 6. Okay? All right, my next point is 1, 2, 1, 1, 2, 2, 4, 2, 1, 2, 3, 4, 3, 6, 1, 2, 3, 1, 2, 3, 4, 5, 6. Okay, and again, you're seeing a nice line. Okay. when I look at these two lines, okay, I see a lot of things about them that are the same. They both have 4 dots. They both have arrows at each end. They're both kind of going in this sort of way direction. They aren't really parallel. Like you can kind of see if they kept going forever, they would intersect. Okay. In fact, I could figure out where, like if I look, like right, okay, if I had this one on this, okay, I want you to notice that right here, 2, 4, they both have that 2, 4. So 2, 1, 2, 3, 4, and 2, 1, 2, 3, 4. So this is actually where they would intersect, right here, okay, because they both have that point. The other thing that I notice about them is that one of them goes to the origin and one of them doesn't, okay? And it's kind of a funny thing, but if you think about it, it makes sense, okay? In a multiplicative relationship, anytime you put in 0, you're going to get out 0, right? Because 0 times anything is 0. So this graph right here is multiplicative graphs. Always, like every time, always go through the origin. Okay, and that's this thing right here, right? Okay. They always do. Because every time you put 0 in, you get 0 out when you multiply. Okay, you notice this line doesn't hit the origin. And if you think about it, every time you put 0 in and then you add something, you're going to get whatever number you added, right? 0 plus 2 is 2. 0 plus 12 is 12. 0 plus 1 is 1. Yes, I know 0 plus 0 is 0, but that would, we're not going to talk about that one, okay? So, additive relationships, sorry, I'm looking for a different color, taking too long, let's see, additive graphs never go through the origin. Okay? So, and remember, origin's right here. Okay? So, you can actually just look at a graph and tell if it's multiplicative or additive just by what the graph looks like. Isn't that crazy? Okay? So, yeah, that is kind of the like, not so quick and easy, but super comprehensive, additive and multiplicative relationships, okay? So your bottom line is that you've got these kind of formulas that you can follow, and you should now know that multiplicative graphs go through the origin and additive graphs do not.